find your homework from last night? Some of us said we had some questions about it. We had a power outage earlier. Hold up. Let's go back and find it. Internet moving slow. We had an outage this morning. Okay, we got it. All right, so yesterday we went over quite a bit of things. So hopefully you got your math notebook with you. If you haven't started getting a math notebook, you should know by now. That's definitely a must. I give us notes for a reason. Those notes are used to guide you and your thinking. You can't get math just by looking at me, tapping something into Google. That ain't math, but we need to understand it. It says a computer performs a calculation in 2.5 times 10 to the negative 5th seconds to solve a math problem. How long does a computer need to calculate the solutions to 3 times 10 to the 6th math problems? It then told us to write our answer in standard form. And then it had a piece down there to show your work. A lot of you wanted to type me in something from in that text box. Some math you just gotta show it. So kind of work on it. You need to see it. Somebody talk to us. How we start? Keywords. What do they tell us to do? We got a computer that solves one math problem in 2.5 times 10 to the negative 5th seconds. We're trying to see how long will it solve 3 times 10 to the 6th math problems. What do we need to do? Operation.
Multiplication.
This is one problem. We're trying to get this many problems. What operation would that be?
Multiplication.
All right, that's multiplication. So that will be 2.5 times 10 to the negative 5th, being multiplied by 3 times 10 to the 6th. Multiplying with scientific notation. First step on yesterday told us to do what?
Subtract this. Multiply or divide the values.
Good job. Follow your correct notes, Cam, and we multiplying. Multiplying told us to multiply those decimals first. So that would have been 2.5 times 3. We got to learn multiples and facts. 3/4. Okay, I'm about to say 25. Think of quarters. 25 times 3 is 75, so 7.5. All right, we're multiplying. What do we need to do with those exponents?
Yeah.
Good job. We will add those exponents. So then negative 5 plus 6, different signs. So 5 will give us what? 6 minus 5.
1.
Hey, that's kindergarten. Come on. So we got 7.5 times 10 to the 1 power. And then they said write that in standard form. How many times should we shift?
Once.
Which direction?
All right.
Good job. We shift 1 to the right. So that 7.5 times 10 to the 1 will be equal to 75. Most of us had that one correct. Any questions about it? Number two said light travels at approximately 2.998 times 10 to the 5th kilometers per second. There are 6.048 times 10 to the 5th seconds in 1 week. About how many kilometers does light travel in 1 week? What are we doing? What operations?
Multiplication.
I'm finna change it. That's what I'm finna do.
Good job, that is multiplication. So once again, we'll set it up the same. 2.998 times 10 to the fifth is being multiplied by 6.048 times 10 to the fifth. Now for step one, we just said multiplying. What do we do first?
Multiply the decimal digits.
Good job, Mercedes. So we'll multiply 2.998 by 6.048.
$18.131904.
18.131904. Okay. And then, of course, what are we going to do with those exponents?
Add them.
Good job. Add the exponents. 5 plus 5 will get us
10.
So we got 18.13194 times 10 to the 10th power. Now that final step told us to check and make sure what?
It was in scientific.
Notation.
Is this in scientific notation?
No,
All right, so what happens?
we shift to the left.
If I shift left, what happens to my exponent?
Negative.
It changes up, it goes up.
Yes, I gotta add 1 to it. So you should have had 1.83194 times 10 to the 11th. C was the correct answer. Most of you had D, and I think I asked you what happens when you shift that decimal. So remember, if you shift that decimal, you also have to do something with that exponent. Any questions about it?
Miss Kitchens, I got a question. Like, I understand how I did it and how you notify me, but I don't understand how it's wrong. Like, I know I didn't do all the steps. That's what I know for sure. Like, you highlight the 1.83. Never mind.
Because you still had 10. Most of the people that I highlighted had this. They left it as 10 to the 10th, but you shifted the decimal, but you still left your exponent as 10. A lot of us left that exponent the same. So that's why I'm reminded, if we have to shift over, just remember you got to add to that exponent.
All right.
And it was quite a few who did that. Good question, William. Good question. Any other questions before we move? All right, the last step, it was a multi-step problem. So that means we need to do the top first. So now we need those rules for adding. What did adding tell us?
Write them both with the same power of 10.
Good job. Before we can add there, we got to get the same power of 10. So looking at these, do you want to keep 17 or you want to keep 15?
15.
10. All right, now I told you something yesterday. If anytime you have a large exponent, that's the one you keep. But we'll keep the 15. So that means the second one will remain the same, 1.2 times 10 to the 15. So if we changing this exponent to 15, how many times should we shift and in what direction?
Twice to the left.
Sure that's to the left? Now
Right.
We said earlier, we add and go left. 1, 2, we got to go to the right. So now that would be 620 times 10 to the 15th. And we're going to add that to 1.2 times 10 to the 15th. 620 plus 1.2.
621.2.
621.2 times 10 to the 15th power. Is it in scientific notation?
No.
All right. So if we shift, what happens?
You shift left twice and add 2.
Good job. Shift left twice, add 2. So now we got 6.212 times 10 to the 17th power. That's why I said earlier, Mercedes, it's always best to keep the largest. That way we wouldn't have the shift in the end, but if we want to keep the smallest, we'll still get the same answer. So now we got 6.212 times 10 to the 7 will be divided by 4 times 10 to the negative 6. To divide, what are we going to do first?
Divide the decimal values.
Good job. We're going to divide those decimal values. I love how William always got those notes with him in case he needs to refer to it. Great. All right, somebody divide it out for us.
1.553.
1.553. What do we do with those exponents?
Subtract them.
All right, 17 minus a negative 6. So we also have to make sure we pay attention to that part as well. Subtract, and then it was a negative. So that would have went to 17 plus 6.
23.
23. So you should have ended up with 1.553 times 10 to the 23rd power. Any questions about it? All right, got a few head shakes. We good. All right, everybody got what we need. All right, so today we're going to continue to look at order scientific notation as well as review some things that we learned on last week. All right, I'm going to give you about 30 seconds to a minute to have a look at this problem. You should have your math notebook. Look back through. Remember I said you can use a notes on anything we're dealing with math. Give you about 30 seconds to a minute. All right, Kalia, if you dare talk to us. Come on, talk to us.
I was looking for my notes. I'm reading my notes.
Madeline, you got something to tell us?
I know.
Hold on, Ken, hold on. I'm trying to get these people I haven't heard from this morning.
What number is a rational number? A rational number.
All right, and if you don't have an answer, at least tell us what we know about rational.
A rational number is. Hold on, let me get it on my notes.
Okay. If you've
A
been
number
listening,
that can be reciprocal as the quantity of a two-part integer, such as Q and 0, or Q and O.
I don't think I gave you that definition, but I'm with you. So a rational number is any number that can be written as a fraction. Any number that can be written as a fraction. We discussed that before. She's telling us some cubes. So that would be perfect squares and cubes. For all of you who have been missing class and you do not know this, your hand should be moving in that math notebook. What else could be a rational number?
Decimals.
I want to ask you for an answer, but okay. Decimals, terminating and repeating. I see kids I ain't never seen and your hands still not moving in the math notebook. Something wrong with it. All right, Cammy, you said 13/19. What tell you that's rational?
Ma'am?
Who was that said 13/19?
That was me.
Oh, Alexia. Why you say 13/19?
Because they are expressed as fractions.
Good job. It's already looked like a fraction. So yes, that'll work. So fractions are rational. William told us decimals, terminating, and repeating. Do we have any decimals that will fall into that category?
A.
Repeating decimals, all repeating decimals can be written as fractions. All right, any other decimals we see that may be rational?
D. And D.
All right,
Oh,
D.
D.
All right, hold on, my D person. Hold on, that D person. This is a terminating decimal because it stopped. Zawa, I think that was you who said D.
I said D.
D.
Why you say D? What that equals?
It says a perfect square and 49 squared is 7.
Good job. Not just 7. Don't forget those squares have two answers, the positive and the negative. Great job. It is a perfect square. All right, what about the square root of 10?
No.
Okay, it's probably not in your chart, so that means it's not a perfect square. So that means the square root of 10 would be irrational. All right, and what about the symbol for pi?
It's a symbol, so it's not rational.
Good job, Mercedes. Symbols are irrational. Great job. And some of these types of questions was on your test on last week, so it's a review. So that means tomorrow we're still going to be looking at some of the same information that includes rational and irrational numbers.
Miss Kitchens,
Uh-huh.
I have a question. You know how you said A is a repeating decimal and E is the terminating decimal?
Mm-hmm.
Like say if if you took if 45 didn't go on, would that be a terminating decimal?
You mean if we got rid of that fraction bar?
Yes.
Yes, it would be terminating if the fraction bar wasn't there. Yes.
All right.
All right, and the typical decimals that be irrational, they are usually right on something about like this, 3.14578813, but they usually always place a little dot, dot, dot at the end to remind you, hey, this number is gonna go on and on and on. So if we don't see that little dot, dot, dot at the end, it's pretty much a terminating decimal. Good question, William. All right, I'm gonna give you about 30 seconds to a minute to have a look at this problem. It dealt with integer exponents. If you're finding it in your notes, integer exponents. All right. It says, which of these is equivalent to 3 to the second power? Is anyone able to figure out at least one?
D.
E.
Say D or B.
D.
I say E.
That was Candy said D. We see 3 2 times, so 3 squared. I agree with you. William, you said E. Talk to us.
Because the rule 2, divided with powers with the same base, you subtract the exponent. So 3 and 3 is the same base. 12 minus 10 is 2.
Good job. That rule, divide with the same base. Subtract exponent, so 12 minus 10 will give us 2. So it can be rewritten as 3 to the second power. Good job, William. All right, did anybody find any others?
I feel like there's one more, and I thought it was B, but I don't know. I don't think that's right. Well, yeah. No, never mind. I'm tripping. No.
All right, so we can look at B. What's 6 squared?
6 squared is 3.
36.
Not
36.
36 divided by 2.
Six.
18. 3 squared will get us to 9. So no, B won't work. What about 8? That's dividing with the same base. 8 minus 4 will get us to 4. So that's why it won't work. C, we are multiplying with the same base.
So that would be 3 to the 8th power. Or 3 to 15.
You
Add
add
the exponents.
Yeah, so 3 to the 8th power is what that would be.
Good job. 3 to the 8th power. F, we are dividing with the same base, so we can subtract -3 minus a -5, which could be rewritten as -3 plus 5. What's 5 minus 3?
2.
It's 2.
Good job. So that means F will work. Any questions about it?
No.
Great job, you 2, 3. Everybody got what you need?
Yes.
Yeah, ma'am.
All right, I'm gonna give you about 30 seconds to a minute. All right, it says express 0.54 repeat as a fraction. How do we change these repeating decimals to fractions?
First, you see the number of places 0.54 is in the hundreds place. That'll be 54 over 100. Then
What
go
is
simple.
decimal place? He said it'll be 54 over 100. Okay.
You gotta subtract 1 from the 100.
All right. Subtract 1 from that denominator. So now what's our denominator?
99.
99.
So now we have 54 over 99. What's that final step?
Dividing by 3.
Divide 54 by 9.
Simplify. Yeah.
She said they both can be divided by 3.
So 99 divided by 3 is 33.
Okay.
And 54 divided by 3 is 18.
18.
All right. 1833 also got 3 in common.
6 over 11.
Good
11.
job. 611. Now, a lot of us had a question like this incorrect on that test on last week. So remember, repeated fractions, repeated decimals. Yes, that last place is in the hundreds, but since it's a repeated digit, you have to subtract 1 from that denominator. Any questions about it? Okay, dokie. All right, I'm gonna give you about 30 seconds to a minute. You might have your square and cube chart in your notes. All right, it says, which pair shows items that have the same value?
B.
Talk to us, Cameron.
A.
I said B because I didn't say A because 64 to the 64 cubed is an 8 squared is 64, not cubed. So that wouldn't be right.
Hold on, there is a cube for 64. There is a cube for 64.
8 times 8 is 64.
That's a cube, so that would mean 4 times 4 times 4. Look at each one separately before you decide, because this is still completely different. And square root of 8, that's not a perfect square. So you won't even have a whole number value for it.
Well, I said B because 9 times 9 times 9 will make 27.
You sure? 9 times 9 times?
No, never mind. Oh, let me look at my chart.
3 times 3 times 3.
Yeah. So that wouldn't be right.
That's my period. 3 times 3 times 3 will get us 27. But does 3 times 3 get us 81?
No.
No.
Okay, so
No.
this was 3 and that was 9. So that one
D.
worked.
The square root of, yeah.
It's D.
Yeah, D.
I hear several of you. Zyla, somebody else. Come on. What you got?
6 times 6 times 6.
And 6 times 6 is 36.
Okay, good job. D will be the correct answer. So definitely make sure we remember a cube is a number multiplied by itself 3 times to get that value. And then a square is a number multiplied twice to get that value. And then if I just forget, place that in the calculator, get the whole number for it, and keep it moving. But you also got some charts in your notes, at least you should. But if not, we know how to get there. Any questions about it?
No.
Awesome, awesome, awesome. All right, I'm gonna give you about 30 seconds to a minute. All right, it reads as follows. The volume of a cube is 125 centimeters cubed. The area of a square is 64 centimeters squared. How does the length of one edge of the cube compare to the length of the edge of the square?
The volume equal length times width times height.
All right, or in other words, S cubed, and then they gave us 125. So we'll take the cube root of 125. Was that one in your chart?
It's 5.
Okay.
It's 5.
And then we got area. We should know by now, area is length times width. With a square, they'll give it to us as side squared. So then that would be defined the square root of 64. Do we know what that is?
8.
8.
All right, so how do these side lengths compare? Comparison, that's less than, greater than, equal to. How do these side lengths compare?
5 is less than 8.
All right, so we'll say the volume of the cube side length of 5 is less than the area of the square side length of 8. So remember, an explanation don't have to be long and drawn out. If you got work to go along with it, that'll kind of help it out, and then just tell what it is. But comparison is still the same as it is in lower grade. Less than, greater than, or equal to. Good job. Any questions about it?
No.
Everybody have what we need? Okie dokie. All right, 30 seconds to a minute. All right, it says the surface area of a cube is 96 inches squared. And then they asked us what's the volume of the cube. Before we can look at the bottom, we need to tackle this top. What do we know about surface area?
It's the total amount.
All right, it's the area of all the faces. And how many faces does a cube have?
6.
Good job.
10.
So we know that 96 involves 6 different faces. So we're gonna go ahead and divide it out. Somebody help us out. 96 divided by 6.
16.
16. So that's the area of one face. So then the cube root of that 16, when the square root of that 16 will give us what?
4.
Good job. Now they want us to find volume. How can we now find the volume? All right, somebody told us earlier that was length time, width time, height. What did we just say the length of that side was?
4.
All right, so that would be 4 times 4 times 4, or 4 cubed, to get us what?
64.
Good job.
Okay.
So sometimes it's a 2-part question. We just have to break it apart and take it one piece at a time and slowly get there. Any questions about it? Awesome. If I seem to be going fast, I apologize. I'm just trying to review some of these questions before we have another look at it tomorrow. All right, I'm gonna give you about 30 seconds to a minute. All right, it says, use scientific notation to find 508 billion times 0.000073. They did say it right there, saying scientific notation and in standard form. How can we get started?
Go ahead and make them into scientific notation. So
Good job. Scientific notation told us we need one number in front of that decimal.
it'd be 5.08 3, 9,
11.
11 to the 10 to 11 power.
11, okay. All right. What we got?
7.3 times 10 to the 6th power.
Sure that's positive 6.
That's a negative.
Negative.
So make sure we know these large numbers get a positive exponent and these small numbers get a negative exponent. Good job, ladies and gentlemen. All right, so now that we have them both in scientific notation, what can we do?
Or multiply.
We multiply the decimal digits.
All right, so that'll be 5.08 times 7.3.
37.084.
37 point what?
084.
0.84.
Yes, ma'am.
Okay, it sounds like you were mumbling a little bit. All right, so now what are we gonna do with those exponents?
Add them.
All right, so add those exponents. 11 plus a negative 6 or 11 minus 6 will give us what?
5.
So now we have 37.084 times 10 to the 5th power. Is that in scientific notation?
Yes.
No.
All right,
No.
William, what we need to do?
Shift it to the left.
All right, we shift to the left. What's gonna happen with that exponent?
It goes up.
All right, add 1 to it. So now we got 3.7084 times 10 to the 6th power. All right, and they also said not only put it in scientific notation, but to put it in standard. So then to go to standard, we're just gonna take that exponent and shift over 6 times. Fill in missing places with placeholders. So we should end up with 3,708,400. Any questions? Did I lose anybody? All right. Your homework tonight, it will be a vocabulary review. You will be given vocabulary words and you will have to give an example for them. That will be vocabulary that's dating back to when school started. So if you have your math notebook, it would definitely help you out with that assignment. Tomorrow you will have a mini review on everything we have kind of been over since the start of school. So we're still going back over and which will help you for that retest. Some of you have started on your retest and some of you have still not. Tomorrow is Friday, so definitely make sure you are working on getting that retest complete. I hope you all have a great Thursday.